Okay, so example number 4. For example, it says that one page of a telephone directory, there were 200 phone numbers. On one page we had 200 phone numbers. So 200 phone numbers, the frequency distribution of their unit place digit, for example, in the number, for example, you know what the unit place is. For example, in this number, the unit place is 0. This first 0 over here is the unit place. The unit place digit. This is called the unit place digit. So it says that the frequency distribution of their unit place digit is given in this table down here. Meaning that we had for example, the digit and the frequency of that digit. So we had 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we had 22, for example, 26, 22, 22, and 20, 10, 14, 20, 10, 14, 28, 16, and 20. So then, without looking at the page, the pencil is placed on one of these numbers. So you have all of those numbers. This is the frequency of their unit place digit. And you have 200 numbers on a page. So you take your pencil and just randomly put it on some number. That is, the number is chosen at random. Okay, so what is the probability that the digit in its unit place is 6? So if the unit place is basically 6, basically the frequency of 6 over here is 14. That means that basically out of the 200 phone numbers, there were basically 14 numbers in which the unit place was 6. Okay, so that means that you can, now the question is, what is the probability that the digit in its unit place is 6? So now if I calculate the probability of basically of the event that the unit place is 6, so if I take the event that the unit place is 6, the event that happens is basically that has happened basically 14 times, and 14 out of 200 times. So that has happened 14 times. So now and if I call this event, for example, I don't know, E, for example, so then P of E is equal to basically the number of times this event has occurred, which is basically 14 divided by the total number of times that the experiment has been basically performed. And what that means is that basically we had 200 phone numbers there. So 14 divided by 200 is equal to 7 divided by 100, which is something like 7 divided by 100 is equal to, for example, 0.000, and 7 is equal to 0.07. So the probability is 0.07. So you can similarly obtain the empirical probabilities of the occurrence of the numbers having the other digits in the unit place. That is basically how you solve this problem, for example. Now, question number 5 is the record of a weather station shows that out of the past 250 consecutive days, its weather forecasts were correct 175 times. So, the record of a weather forecast station shows that out of the past 250 consecutive days, the weather forecast was correct 175 times, right? Now, what is the probability that on a given day it was correct? The probability that on a given day it was correct, it's basically, if I want to write it a little bit neat and clean, I would write it as P of the forecast was correct on a given day. P of the forecast was correct on a given day. It was basically the number of days in which the weather forecast was correct, which is 175, divided by the total number of days, which is 250, and that's equal to 175 divided by 5 is equal to 3 times 5 is equal to 15, 25, 5 times 5, that's 35, divided by 5, 35, divided by 5, 50. And divide by 5, 7, divide by 5, 10, 7 tenths is 0.7. Now, the second question is, what is the probability that it was not correct on a given day? So now the P, or probability of the weather forecast or the forecast was not correct on a given day is basically the number of days in which the weather forecast was not correct divided by the total number of days. Total number of days is still 250. And we had basically 250 days. And on these 250 days, basically 175 days, this is the total, and on 175 days, the weather forecast was correct. So now if you want to calculate the number of days on which the weather forecast was not correct, you have to divide to basically subtract 175 plus 250. So 250 minus 175 is equal to 10 minus 5 is equal to, let me write it that way. So you can write this as 1, 15, 14, and 10, 5, 7, and that's 75 days. So that means that on 75 days, the weather forecast was not correct. Right? So I can write here 75 divided by 250, which is equal to divide by 75 divided by 5 is equal to 1 times 5 is equal to 15, and 250 divided by 5 is equal to 50. Divide by 5 you'll get 3, divide by 5 you'll get 10, 3 tenths, which is equal to 0.3. And as you can see, 0.7 plus 0.3 is equal to 1. That means that the probability of the forecast was not correct on a given day, and the probability of the probability that the forecast was not actually, I'm sorry, I need to repeat this. The probability that the weather forecast was given was correct on a given day, plus the probability that the forecast was not correct on a given day, basically the negation of that is basically, if you add those two probabilities together, you will get a 1. We have another question here. Okay, so then there is another question here, example number 6, which is about a tire manufacturing company, which I think has logical problem. It has some logical problem. I remember that I tried to solve this problem the previous time that I was reading this book. I tried to solve this problem, but I couldn't. And well, then I took a look at the solution. I didn't understand it. Well, and then I passed by. But now that I think about it, the problem has not been solved in the right way. So I think there is, I mean, they have made it. There is no problem with the calculation or anything, but there is a logical mistake in how they have solved the problem. So I'm not going to bother about that really. And there is a couple more examples here. Oh, there is a lot. There is still a couple of them. So we have example number 7. It says that the percentage of marks obtained by a student in the monthly unit tests are given below. So you have basically, you have the unit test. You know what the unit test is. I think in schools, in colleges, in basically in institutions, when they basically complete a unit, then they take a test, and then they call it a unit test. So, for example, related to some book or some subject. So the unit test, and then here you have the percentage of marks obtained. Percentage of marks obtained. And 1, 2, 3, 4, and 5. So this was unit test 1, unit test 2, unit test 3, 4, and 5. This is 3, 4, and 5. And so basically the percentage of marks obtained What is the percentage of marks obtained? I see. The percentage of marks obtained by a student. So this is, write this properly. So this is number 3, number 4, and number 5, and these are the percentage. So that's 69%, for example. This is 71%, 73%, this is 68%, and 74%, right? So these are the percentages of marks obtained by a student, by just one student, related to these unit tests, unit test 1, 2, 3, 4, and 5. In a monthly unit, in the monthly unit tests are given here. So now based on this data, you want to find the probability that the student gets more than 70% marks in a unit test. So you want to find the probability that the student gets more than 70% in a unit test. So the number of basically more than 70% has happened. Basically more than 70% has happened here, and has happened here. So 3 times out of, so if I call this, for example, if I call this event E of, well, just simply E, then P of this event would be equal to the number of times that this event happened, which was 3, and the total number of exams that we had were 5. So 3/5, which is 0.6. So the total number of unit tests held is 5, and the number of unit tests in which the student obtained more than 70% marks is 3. So 3 divided by 5 is equal to 0.6. Now the next question is, an insurance company selected 2,000 drivers at random, that is without any preference of one driver over another. Okay, so the insurance company selected 2,000 drivers at random, meaning just randomly selecting 2,000 drivers without any preferences of one driver over another, meaning that not taking into consideration any criteria or anything, just 2,000 drivers randomly in a particular city to find the relationship between age and accidents. To find the relationship between age and accident. The data obtained are given in the following table. So now they have put together the data that they have found in this table. So we have the age of drivers in years. You have the age of the drivers in years, and that's 18 to, for example, 29, 30 to 50, and above 50. And then you have accidents in 1 year. So over here you have basically over here, let me see, you have accidents in 1 year, and then over here you have 0, 1, 2, 3, and over 3. And let me clear this out, and then let me okay. Now, as I remember, this example was also trouble the previous time that I wanted to solve it. So you have basically 440, 505, 505, 360, then you have 160, 125, and 45, and then you have 110, 60, 35, 61, 22, 15, 35, 18, and 9. Okay, so what that is basically, so this insurance company has selected 2,000 drivers at random without taking into consideration anything, just picking randomly 2,000 drivers to find a relationship between age and accidents. So these are the ages of these drivers, and these are the number of accidents that have happened in 1 year. And this is the data that they have obtained. So let me take a few minutes rest. I'll be back with the rest of this. Okay, so now the questions that we need to answer here are: find the probabilities of the following events for a driver chosen at random from the city. So since basically the driver has been chosen at random and the data has been put in this table for the same driver, so I don't need to worry about that part of the question. So that the driver has been already chosen at random, and all of this data is related to drivers chosen at random. From the city, from the city is the data has been collected from the city. So now what we need to do is find the probabilities of the following events for a driver. Now, being 18 to 29 years of age, so you want to find the probabilities for a driver, number one, being 18 to 29 years old and having exactly 3 accidents in 1 year, and having had, well, you can say having as well, because it could mean both of them. So having exactly 3 accidents in a year, in 1 year. So these are all accidents in 1 year, so I don't need to worry about this part of the question, right? So this is already taken care of. And then it says having exactly 3 accidents. So over here we have 0 accidents, 1 accident, 2 accidents, 3 accidents, and this is over 3 accidents. This is over 3 accidents. So I'm looking for this data. And being 18 to 29 years of age, so 18 to 29, so that means that the drivers who were between 18 to 29 years old and had 3 accidents in a year, in 1 year, the number of them was basically 61. That means that this event, if I call it whatever I can call it, for example, E1, this event happened 61 times. Out of how many times? Out of meaning that the total number of the total number of accidents happening was so 0 accidents happening was 440 times. 440, 160, 110, 61, 35. And then over here you have something about, this is around 900, 1200, and this is about 1300. That means that if you add all of these numbers together, you'll get a 2000. But that doesn't make much sense, because if you have 440 plus 505 plus 360 plus 160 plus 125, 45, 110, 60, 35, 61, 22, 15, 35, 18, and 9, you get exactly 2000. Okay, so what that means is that we have run the experiment for we have run the experiment for 2000 times, and in 2000 times we have performed this experiment for 2000 times, meaning for 2000 drivers. And basically this event has occurred 61 times. So that's 61 out of 2000. So that means that P of E1 is equal to 61 over 2000, which is the same thing as if I divide basically 61 divided by 2, I get 30.5. 30.5 divided by 1000, which is the same thing as 0.0305. So that is the probability of that event happening, if I'm not mistaken. So that's that's approximately 0.031, right? So this answer is correct. So it says that basically the total number of drivers who are 18 to 29 years old and have exactly 3 accidents in 1 year is 61. So and the total number of drivers is 2000. And you do need to understand the situation, and then, for example, but what you generally consider as the formula that you apply here is that the probability of some event E happening is equal to basically the number of times that the event E occurred, the number of times that E, or the event E occurred, and I think occurred must be written with 2 R's. Occur with 2 R's, right? So occurred over the total number of times that the experiment was performed. And let me write this better than this. The total number of times if I were to write this even better than this, I would write it as I wrote it before, which is the number of trials in which the event happened. Number of trials in which the event E happened or occurred, the same thing, divided by the total number of trials. Total number of trials. If you have this in mind, you will not make mistakes, because in different situations this means different things, meaning that you need to take different numbers into consideration. So you need to fit this into different situations. So if you do that, you will not get into trouble. Otherwise, you might take some number for example, the total number, and then that number might actually not be the number that you were supposed to take in that situation. So it's the number of trials in which the event E happened divided by the total number of trials. So that is that. Now, the next question that we want to answer here is part 2 of this question, which I call E2, which I call event 2 or E2. So let me go back to where I was in this book, number, I don't know, I was over here. Being 30 to 50 years of age, being 30 to 50 years old, and there is years over here, years old, and having one or more accidents in a year, and having one or more accidents in a year. So being 30 to 50 years old and having one or more accidents in a year. So basically the number of one or more accidents, that means that this one accident will be basically a part of this question, or will have to be counted here. 2 has to be counted, 3 has to be counted, and over 3 has to be counted as well. So 30 to 50, that was basically 125, 60, 22, and 18. You add all of these numbers together. So then P of E2 would be equal to, for example, something like 125, one or more accidents, 125 plus 60 plus 22 plus 18 divided by the total number of trials, which is 2000 in this case. So that is equal to 88, 98 plus 8 is equal to whatever that is, plus 125. 16 plus 5 is equal to 21. 16 plus 5 is equal to 21. So you have 4 plus 9 is equal to 13, and 231. That's 231 divided by 2000. So that's equal to, divide by 2, you will get 130 is 15, 115.5. 115.5, and divided by and divide this by 2, you'll get 1,000, and so you'll get 0.1155. 0.1155. So 125 plus 225. Oh, I made a mistake somewhere over here. So let me see, 125 plus 66 plus 22 plus 18 is equal to 231. $125 plus 60 plus 22 plus 18 is 225. No, it's 231. I never knew they would make mistakes in this book, but it seems that they have. You see, 125 plus 60. Oh, that's 66. That's not 66. Okay, no, that's my mistake. That's 60. Actually, I have written 60, but I read that as 66. I'm sorry. Okay, so that is what was the number? 225. 225 divided by 2000. Divide this by 2, you will get 110. 112.5 divided by 1000, which is equal to 0.1125, which is the same thing as which is approximately 0.113. 113. So that is that. And then the third part of this question, having no accidents in 1 year. The third part of this question is having no accidents in 1 year. So over here, as you can see, the age is not important anymore. So you have to count all the people that had no accidents across all the age groups. So you have to count 440, 505, and 360. So if I call this, for example, event 3 or E3, then P of E3 would be equal to basically would be equal to 440, 505, 440, 505 plus 360, and divide that by 2000, which is the total number of trials. So that gives you 945, 440, 505, and 360. Get a 5 there, you get a 0, 1, 5, so that's a 10, 13, 1305. That's 1305 divided by 2000, which is equal to, divide this by 2, you will get 500, and 300, 150, and 5 would be 2.5. So you'll get 2.5 over here. 5 is 652. 652.5 divided by 1000, which is the same thing as 0.6525. So, which you can take as 653, for example, approximately 0.653. So now let's do the next question as well, which is let me do it down here. Probably will have enough space here. Okay. So it says consider the frequency distribution table 14.3, example 4, chapter 14, which gives the weights of 38 students of a class. So I have to go chapter 14. Let me see. This is class, I suppose, 11, 10, and 9. 11, 10, and 9. This is class 9. This is class 9. Chapter 14. And we need to go for table Table 14.3. 14.3. Okay, so this is table 14.3. So table 14.2, I need more space here. Okay, so 431. And so I have this this basically continuous frequency distribution table, which is weights in kilogram, weight in kilogram, and over here I have number of students, number of students. And then I have over here I have these classes, which are 31 to, for example, 35, 36 to 40, and it's not continuous. 35, 36, it's not continuous. 41 to 45, and 46 to 50, and 51 to 55, and 56 to 60, and 61 to 65, and 66 to 70, and then you have 71 to 75. And then the number of students is, or the frequency for these are 9, 5, 14, 9, 5, 14, 3, 1, 2, 2. So 3, 1, 2, and 2, and 1, and 1. Okay, so we have this information here. We have this information here that is basically the information that I have. You don't have to make it pretty, but pretty is, well, pretty. Now, so I have this information, and consider the frequency distribution table, which gives the weights of 38 students of a class. These are supposed to be 38 students. So now what you want to do is that you want to find the probability that the weight of a student in the class lies in the interval 46 to 50. You want to find the probability that the weight of a student lies in the interval 46 to 50 kilograms. 46 to 50 kilograms. So 46 to 50 kilograms goes, that's exactly 46 to 50 kilograms, so you don't have to do much here. And basically the number of those students was 3, if I call this, for example, E1, if I call this E1, so the weight of a student lies in this interval 46 to 50. So the total number of students was 38 students. So that means that P of E1, you can write it as 3 divided by 38, which is the same thing as, I don't know, the same thing as 3 divided by 38, which is basically 0 plus 0, and then 407, 38 times 7 is equal to 2156. That's 266, and 38 times 8 is equal to 240 and 64, 240, 64, 304. So that's 7 times. 7 times 38 is equal to 266, and 2, 9, and 10, so you get 6, a 4 here, a 3 here, and 0, 0, 340. So I suppose 9 times 38 times 9 is equal to 72, 7, 27, plus 7 is equal to 34, 342. So 8 times would be some number like 304, and then you will get some 36 remainder. So I can take this as approximately 0.08. 0.08. Okay. Now, also another part of this question, give 2 events in this context on having probability 0 and the other having probability 1. So probability 0 means that some event has not happened. So for example, you could say that the event, the probability that the weight of a student, for example, is I don't know if I can, for example, use some sort of information that is not provided in the table. For example, if I say that the weight of a student was less than 31 kilograms or so, for example, less than 31 kilograms, then I might be allowed to use that as an event that never happened based on this table. Of course, I don't know that, because this table gives me the information about that it gives me. It doesn't necessarily tell me that what there isn't in the table has never happened. Probably they have happened, but they have not. They have not simply written the information here. So what you can do, okay. Well, that works. I can actually do that. For example, I can say that the probability of the event that a student, for example, weighs 30 kilograms, right? Now, this basically, the information that I have here is strictly about 38 students, and all of these 38 students have been put into all of these groups. That means that among these 38 students, there was no student whose weight was, for example, 30 kilograms, because all of these students, their weight is above 31 kilograms, right? So there was no student whose weight was, for example, 30 kilograms or 20 kilograms or 25 kilograms. So that means that the probability of that is 0. And the probability of, for example, the probability as an example for a probability 1, you can say that for example the probability that the weight of a student was between 31 and 75 kilograms. Or similarly, the probability of a student weighing more than 30 kilograms. More than 30 kilograms is also acceptable, because that would be basically all of these numbers. More than 30 kilograms starts from 31, goes all the way up to 75. That the number would be 38 divided by 38 is equal to 1. But of course there is a logical problem here, meaning that if I say more than 30 kilograms, then more than 30 would basically include, for example, 80 kilograms as well. But there was no student here whose weight was 80 kilograms. The weight of all of these students was between 31 and 75. So that's not entirely correct. I should say that, for example, the probability that the weight of a student lies between, for example, 31 and 75, and that's absolutely correct.